Every star you see tonight belongs to the past. Not metaphorically, not poetically, literally. And once you realize what that truly means, the night sky may never look the same again. Right now, somewhere above you, countless points of light are shining through the darkness. They seem immediate, present, alive in this very moment. But what if I told you that not a single one of those stars is showing you the universe as it exists now? What if the sky above your head is actually a vast archive of ancient history, a museum of light, a collection of messages sent across unimaginable distances long before this night ever arrived? Some of the starlight reaching your eyes tonight began its journey before you were born. Some left its star before your parents were born. Some started traveling toward Earth before entire nations existed. And some of the faintest lights visible through powerful telescopes began their journey long before human civilization had even learned to write. The night sky is not a window into the present. It is a window into the past, a natural time machine that surrounds us every evening. And unlike the time machines of science fiction, this one is real. In fact, it is operating right now. As you rest here tonight, as you listen quietly, as the world slowly settles into darkness, light itself is the reason. Although light travels incredibly fast, nearly 300,000 kilometers every second, it does not travel infinitely fast. It takes time. Even the sunlight warming Earth right now is slightly old. The light leaving the sun requires about 8 minutes to reach our planet. That means whenever you look at the sun, you are seeing it as it was 8 minutes ago. If the sun could somehow disappear instantly, a completely impossible scenario but useful for imagination, we would not know for 8 whole minutes. The sky would continue looking perfectly normal. The sunlight would continue shining. The universe would keep its secret until the final photons arrived. 8 minutes may not sound impressive, but stars are much farther away. The nearest star beyond our sun is Proxima Centauri. Its light takes more than 4 years to reach Earth. When astronomers observe Proxima Centauri tonight, they are not seeing what is happening there today. They are seeing what happened over 4 years ago. Every observation is delayed. Every glimpse arrives late. The universe always speaks to us through memory. And as distances grow larger, those memories become older, far older. Imagine a star located 100 light years away. The light entering your eyes tonight left that star when people on Earth were living 100 years in the past. Long before smartphones, long before satellites, long before modern computers transformed everyday life. That star is showing you a version of reality that no longer exists. It is sending you a postcard from another era. Now imagine a star 1,000 light years away. The light reaching Earth tonight began traveling before airplanes crossed oceans regularly, before television, before most of the technologies we take for granted. The farther we look, the deeper we travel into history, and eventually we leave human history behind entirely. Astronomers observe distant galaxies, millions of light years away. Some are so distant that the light reaching our telescopes began its journey before the first human ancestors walked upright. Others reveal events that occurred before Earth even existed. The most powerful telescopes ever built can detect light that has traveled for more than 13 billion years. That means they are looking back toward the earliest chapters of cosmic history, toward a universe that was still young, toward the dawn of stars, toward the first galaxies emerging from darkness. When scientists point their instruments toward deep space, they are also pointing them backward through time. The deeper they look, the older the universe becomes. This is one of the strangest truths in astronomy. Distance and time become linked together. To travel farther into space is to travel farther into the past. The cosmos preserves its own history in light. Every photon carries a timestamp. Every beam of starlight is a messenger. Every night sky is filled with ancient stories still arriving. Perhaps that is why stargazing can feel so different from looking at anything else. When you look at a tree, you see it almost exactly as it is. When you look at a mountain, the delay is tiny, practically meaningless. But when you look at the stars, you are seeing ancient events unfolding long after they happened. You are witnessing history, and sometimes that history contains surprises. Some stars, visible in the night sky, may no longer exist. Massive stars can live relatively short lives, A few million years, a cosmic blink. If a distant star exploded hundreds or thousands of years ago, its final light might still be traveling toward us. From Earth, the star would appear perfectly normal. We would have no warning. Only when the final message arrives would we discover what happened. Imagine that for a moment. A star shining peacefully above us. Beautiful, steady, calm. Yet unknown to everyone on Earth, it may already be gone. Its light simply has not finished crossing the enormous gulf between us. The universe keeps many secrets this way, not through silence, but through distance. And perhaps there is something strangely comforting about that. The night sky reminds us that reality is larger than our immediate moment, older than our oldest memories, more patient than our fastest thoughts. The stars teach us that time flows differently on cosmic scales. Civilizations rise and fall. Generations come and go. Entire chapters of human history pass like brief flashes. Yet the light continues traveling, crossing darkness, crossing centuries, crossing unimaginable distances, until one quiet night, it finally reaches a small world orbiting an ordinary yellow star. And someone looks up, someone pauses, someone wonders. And for a brief moment, they become connected to a story that began long before they were born. A story written in starlight. A story still unfolding above us tonight. Because every star you see in the darkness is more than a point of light. It is a message from another time. A traveler from the past. A reminder that the universe is not only vast in space, but vast in time. On certain worlds, the sun never truly sets. Daylight can last for years. Not days, not weeks, but years. Imagine stepping outside and watching the sun hang above the horizon, day after day, month after month, year after year. No sunset, no twilight, no stars emerging overhead, no darkness to signal the end of the day, only an endless sky flooded with light. At first, it might sound beautiful, a world without night, a place where sunlight never abandons the landscape, a planet bathed in permanent dawn. But the longer you imagine it, the stranger it becomes. Because here on Earth, darkness shapes almost every aspect of life. Our bodies evolved beneath a cycle of day and night. Plants follow it. Animals follow it. Even our thoughts and emotions are influenced by the changing rhythm of sunlight and darkness. Night gives the world a chance to rest. But elsewhere in the universe, nature follows very different rules. There are worlds where the familiar cycle of sunrise and sunset simply does not exist. Some orbit their stars in ways that create days lasting months or even years. Others rotate so slowly that entire civilizations, if they existed, might experience only a handful of sunsets in a lifetime. And some planets may never truly know night at all. One of the strangest examples involves a phenomenon called tidal locking. It sounds complicated, but the idea is surprisingly simple. Imagine a world orbiting very close to its star. Over millions of years, gravity gradually slows the planet's rotation until one side always faces the star. The same face remains permanently illuminated. The opposite side remains trapped in eternal darkness. This is exactly what our moon does with Earth. Whenever you look up and see the moon, you are seeing the same side that humans have always seen. Its far side remained completely hidden until spacecraft finally revealed it. Now imagine an entire planet behaving this way around its star. One hemisphere experiences endless daylight. The other hemisphere experiences endless night. The sun never moves across the sky. It simply hangs in the same position forever. For anyone standing near the center of the day side, the star would appear frozen overhead. Hour after hour, year after year, century after century. The landscape beneath that eternal sun could become unimaginably hot. Deserts might stretch beyond the horizon. Rock could bake under constant radiation. Clouds might form strange patterns as atmospheric currents struggle to transport heat toward the dark side. Meanwhile, the opposite hemisphere would exist in perpetual darkness, a frozen kingdom where sunlight never arrives. Temperatures could plunge hundreds of degrees below freezing. Ice might accumulate for millions of years. Entire oceans could potentially freeze solid. Between these extremes lies one of the most fascinating regions astronomers can imagine. A narrow band circling the planet where day meets night, a place of eternal sunset. Here, the star would remain forever near the horizon, never rising, never setting. The sky might glow with permanent twilight. Not morning, not evening, just an endless in-between. If life exists on tidally locked worlds, many scientists believe this twilight zone could be one of the most comfortable places to live. Neither too hot nor too cold, a narrow ribbon of habitability separating fire from ice. Even stranger worlds may exist. Some planets orbit red dwarf stars so closely that their years last only a few Earth days. Others travel around binary stars, where two suns share the sky. Imagine standing on such a world. One sun begins to set while another still shines brightly overhead. The landscape glows beneath overlapping shadows. Colors shift constantly. The sky becomes a moving work of art unlike anything seen on Earth. In some regions, true darkness may rarely occur. As one star disappears below the horizon, another emerges. Night becomes brief, a temporary visitor rather than a daily certainty. There are also planets whose rotations are incredibly slow. On Mercury, a single day from sunrise to sunrise lasts about 176 Earth days. Imagine waking up to a dawn that continues for weeks. Imagine watching shadows crawl across the ground so slowly that they appear motionless. Imagine celebrating birthdays while the same sunrise is still unfolding. Life on such a world would experience time differently. The sky itself would move at a pace almost impossible for human intuition to grasp. And then there are planets orbiting near the poles of their stars. Some may experience extreme seasonal cycles, months of uninterrupted daylight followed by months of darkness. We see a small version of this on Earth near the Arctic and Antarctic circles. During summer, the sun can remain above the horizon for weeks. The famous midnight sun transforms the landscape into a place where night temporarily disappears. But elsewhere in the cosmos, these effects can become far more dramatic. Entire years of daylight, entire years of darkness, entire civilizations living according to rhythms unfamiliar to us. When astronomers discover exoplanets, one of the first questions they ask is what the sky might look like there. Would there be sunsets? Would there be seasons? Would the inhabitants, if any existed, ever see stars? These questions may sound poetic, but they are deeply scientific. The pattern of light and darkness affects climate, weather, and potentially life itself. A world without night is not merely a curiosity. It is a fundamentally different environment, a different experience of existence. And perhaps that is one of the most beautiful lessons astronomy offers. The universe does not build worlds according to a single template. Earth is not the standard. It is only one possibility among countless others. Some worlds may know endless storms, some may know endless ice, and somewhere, circling distant stars we have only recently discovered, there may be planets where darkness never arrives. Planets where children, if they exist, grow up beneath skies that have never revealed a single star. Planets where generations live and die beneath the same unchanging sunlight. Planets where sunset is not a daily event, but an unimaginable concept. As you lie here tonight beneath Earth's familiar cycle of darkness, it is worth pausing to appreciate how unusual our world truly is. Every evening, the sun slips below the horizon, the sky darkens, the stars emerge, and the universe reveals itself. But elsewhere, among the countless worlds scattered through the galaxy, there are places where that moment never comes. Places where daylight reigns endlessly. Places stranger than dreams. Places where night itself does not exist. While civilizations appear and disappear, some stars barely change at all, patiently shining through unimaginable ages. Imagine standing beneath the same sky for 1,000 years. You would witness kingdoms rise and collapse. Languages would be born, evolve, and vanish. Cities would grow from empty fields and eventually crumble into ruins. Entire chapters of human history would unfold before your eyes. Yet above it all, the stars would seem almost unchanged. That feeling is not an illusion. Compared to the lifespan of a civilization, many stars are astonishingly eternal. Human history stretches back only a few thousand years, recorded civilization occupies a tiny sliver of time. The pyramids of Egypt feel ancient to us. The Roman Empire feels distant. The earliest cities seem buried in an almost unimaginable past. But to many stars, all of that has happened in the blink of an eye. Our sun is approximately 4.6 billion years old. When it first ignited, Earth itself was a hostile world of molten rock and violent impacts. No oceans existed, no forests swayed in the wind, no animals walked across continents, no human eyes gazed upward. The sun shone anyway, patiently, steadily, wading through ages so vast they challenge comprehension. For hundreds of millions of years, life existed only as simple microscopic organisms. The sun watched. When the first complex creatures appeared in Earth's oceans, the sun was there. When plants transformed the atmosphere, the sun was there. When dinosaurs ruled the planet for more than 160 million years, the sun continued shining above them. And when an asteroid struck Earth, ending their reign, the sun remained unchanged. It illuminated the age of dinosaurs. Then it illuminated the age that followed. The rise and fall of entire worlds unfolded beneath its light. Yet from the sun's perspective, these events happened remarkably quickly. Stars live on timescales that make civilizations appear almost invisible. A human life might last 80 years. A civilization might endure several thousand. A star can burn for billions. The difference is difficult to grasp. Imagine compressing the entire history of human civilization into a single day. In that scale, the lifetime of our sun would stretch for millions of days. Empires that feel enormous to us would become brief flashes. Wars would come and go like passing shadows. Generations would flicker into existence and disappear before a star even noticed. This enormous difference in timescale changes how we think about the universe. We often view ourselves as permanent because our lives are all we know. But stars reveal a different perspective. They remind us that permanence is relative. What feels ancient to humans may still be young in cosmic terms. There are stars far older than our sun. Some formed during the early history of the Milky Way itself. These ancient suns have survived for billions upon billions of years, long before Earth existed, long before the sun formed, long before our solar system emerged from a cloud of dust and gas. These stars were already shining. Imagine what such a star would have witnessed if it could observe the galaxy around it. Entire generations of stars being born and dying. Massive stellar explosions scattering new elements into space. Spiral arms slowly rotating around the galactic center. Countless planetary systems forming from clouds of cosmic debris. Perhaps worlds where life emerged. Perhaps worlds where life disappeared. Perhaps stories we will never know. All while the star itself continued burning quietly, patiently crossing the ages. Red dwarf stars are even more remarkable. These small, dim stars are among the longest-lived objects in existence. Unlike massive stars that burn furiously and die young, red dwarfs consume their fuel with extraordinary efficiency. Many may survive for trillions of years. Not billions, trillions. 1,000 times longer than the current age of the universe. This means something extraordinary. The oldest red dwarfs alive today are still in their infancy. The universe itself has not existed long enough for them to grow old. Their greatest chapters have not yet been written. Most of their future still lies ahead. If life exists around such stars, entire civilizations could rise and fall countless times while their parent star changes very little. Species might evolve, planets might transform, oceans could appear and vanish, ice ages could come and go. Yet overhead, the same red sun would continue glowing, a constant companion across unimaginable stretches of time. There is something strangely comforting about that thought. We often think of the universe as a place of chaos and change, and certainly change exists everywhere. Stars explode, galaxies collide. Planets form and disappear, yet beneath all that motion, there are also enduring rhythms, steady lights that persist through the turbulence, cosmic landmarks that remain while everything around them transforms. Perhaps this is why humans have always looked to the stars. Ancient sailors navigated by them, farmers planned seasons by them, entire mythologies grew around familiar constellations. People separated by thousands of years looked upward and found comfort in the same lights. The stars became symbols of permanence in a changing world, of continuity amid uncertainty, of endurance against time itself. Of course, stars are not truly eternal. Even the longest-lived suns will eventually change. Hydrogen fuel will slowly diminish. New stages of stellar evolution will begin. Every star carries its own future, its own destiny, its own ending. But those endings occur so slowly that they almost transcend ordinary understanding. The sun, for example, is only about halfway through its main lifetime. It will continue shining for roughly another 5 billion years. 5 billion years. That is longer than the entire history of Earth since complex life first appeared. Everything humanity has ever accomplished occupies only a tiny fraction of that future. Every city currently standing will be gone. Every nation will have transformed beyond recognition. Entire chapters of planetary history remain unwritten. Yet the sun will still be there, rising each morning, warming the oceans, lighting the sky, quietly continuing its journey through cosmic time. Perhaps that is one of the most humbling lessons the stars can teach us. Our lives are brief, civilizations are brief, even species are brief. But brief does not mean insignificant. A melody does not need to last forever to be beautiful. A sunset does not need to endure for centuries to matter. Meaning is not measured only by duration. The stars remind us that we are part of a much larger story. A story unfolding across billions of years. A story that began long before we arrived and will continue long after we are gone. Yet for this brief moment, we are here, looking upward, wondering, learning, dreaming, beneath ancient suns that have watched countless ages pass. And somewhere out there tonight, another star may be shining over a distant world, a world with its own oceans, its own mountains, its own history, perhaps even its own observers gazing toward the sky. If they exist, they too may look up and feel the same sense of wonder, the same realization that time is vast, that stars are patient, and that beneath their ancient light, every life becomes part of a story far greater than itself. If you're enjoying this peaceful journey through the cosmos, consider subscribing and joining us for more relaxing adventures among the stars. The universe is often imagined as a place of noise and chaos, exploding stars, colliding galaxies, violent eruptions of energy. Yet, if you could somehow leave Earth behind and drift far beyond the atmosphere, you would discover something surprising. Space itself is silent. Not quiet, not peaceful in the way a forest is peaceful, but truly silent. No wind, no echoes, no distant rumble, no sound at all. Because sound needs matter to travel through. Air carries the sounds of rain and thunder. Water carries the songs of whales across entire oceans. Even solid ground can carry vibrations from distant earthquakes. But the vast majority of space is nearly empty. There is simply nothing there to carry sound. If you floated near a star the size of our sun, you would see oceans of fire twisting across its surface. You would witness eruptions larger than entire planets. You would watch billions of tons of plasma rise and fall in glowing arcs. And yet you would hear nothing. The sight would be overwhelming. The silence would be even more unsettling. Perhaps that is one of the strangest truths in astronomy. The most powerful events in existence happen without a single sound. Somewhere in the distant universe, at this very moment, a star may be exploding in a supernova. For a brief period, that single dying star can shine brighter than an entire galaxy. The explosion releases more energy in seconds than our sun will produce during its entire lifetime. A wave of radiation races outward. Heavy elements are forged. New matter is scattered across space. Future planets are born from the debris. Future oceans, future mountains, perhaps even future living beings. And through all of it, silence. No roar, no blast, no thunder. Only light crossing unimaginable distances. The same is true for black holes. Few objects inspire more fascination than black holes. They are often portrayed as cosmic monsters, endlessly consuming everything around them. But black holes are not cosmic vacuum cleaners. Many spend millions of years doing almost nothing at all, invisible, motionless, silent. Yet beneath that silence lies incredible power. A black hole's gravity can bend space itself. It can redirect the paths of stars. It can distort time. It can trap light. If a star wanders too close, the encounter becomes one of the most dramatic events in the cosmos. Gravity begins to stretch the star. The side closest to the black hole feels a stronger pull than the far side. The difference becomes so extreme that the star is literally pulled apart. Astronomers call this process a tidal disruption event. The name sounds technical. The reality is astonishing. A star that may have shined peacefully for billions of years can be transformed into a glowing stream of gas, spiraling around darkness. From Earth, telescopes observe these events as brilliant flares, appearing suddenly in distant galaxies. For a short time, the black hole announces its presence. Then the light fades. The silence returns. Even entire galaxies can experience similar contrasts. From a distance, galaxies appear calm and timeless, beautiful islands of starlight drifting through darkness. But inside them, enormous forces are constantly at work. Stars are born. Stars die. Clouds of gas collapse. Black holes feed. Gravity reshapes everything. The process unfolds so slowly that it seems peaceful. Yet over millions of years, galaxies can completely transform. A galaxy you see tonight may look serene, but hidden within it are forces powerful enough to rearrange hundreds of billions of stars. This contrast between calm appearances and immense power appears throughout the universe. Consider neutron stars. When a massive star reaches the end of its life, its core may collapse into an object only about 20 kilometers wide. Yet that tiny remnant can contain more mass than our sun. The result is almost impossible to imagine. A teaspoon of neutron star material would weigh billions of tons on Earth. Its gravity becomes extraordinary. Its magnetic fields can be trillions of times stronger than anything we can create in laboratories. And still, if you floated nearby, you would hear nothing. The universe does not need noise to demonstrate strength. In fact, some of its greatest powers reveal themselves through stillness. Astronomers often spend years studying tiny changes in light, a slight dimming, a faint pulse, a subtle shift in color. From these delicate clues, entire worlds are discovered. Invisible planets reveal themselves. Black holes expose their presence. Ancient stars tell their stories. The universe whispers rather than shouts. And perhaps that is part of what makes it so beautiful. When we look up at the night sky, we see countless points of light scattered across darkness. Most seem permanent, stable, unchanging. Yet each one represents forces beyond ordinary comprehension. Fusion burns within stellar cores. Gravity shapes galaxies. Time stretches across billions of years. Everything is moving. Everything is evolving. Everything is alive with energy. Yet from our perspective, it appears calm. The night sky becomes a reminder that appearances can be deceptive. Silence does not mean emptiness. Stillness does not mean weakness. Sometimes the greatest power is hidden beneath the quietest surface. And nowhere is that lesson written more clearly than among the stars. As darkness settles across the universe tonight, countless extraordinary events continue unfolding beyond our view. Stars are being born. Stars are dying. Black holes are feeding. Galaxies are colliding. The cosmos continues its endless transformation. But from Earth, all we see are silent points of light, tiny beacons shining peacefully above us. A gentle reminder that the quietest places in the universe are often the most powerful of all. Stars rarely travel alone. Many move through space surrounded by families of planets, moons, comets, asteroids, and countless smaller objects. When we picture a solar system, we often imagine something fixed in place. A star at the center, planets circling peacefully around it. Everything stable and unmoving against the backdrop of the universe. But that picture is incomplete. The truth is far more fascinating. Every solar system is traveling. Every star is moving. Every planet, moon, and comet is participating in an enormous journey through the galaxy. Right now, as you rest comfortably on Earth, our entire solar system is racing through the Milky Way at extraordinary speed. The sun carries us along at roughly 828,000 kilometers per hour as it circles the center of our galaxy. You do not feel this motion. The oceans do not slosh from side to side. The atmosphere does not tear away. Everything moves together. The sun, the planets, the moons, the asteroids, the distant icy worlds beyond Neptune. All of them travel as a single cosmic family. Imagine standing on a beach at night. The waves move gently. The stars seem fixed overhead. The world feels still. Yet at that very moment, Earth spins on its axis. Earth circles the sun. The solar system moves through the Milky Way. The Milky Way itself drifts through space. Even our local group of galaxies is moving. Stillness, it turns out, is often an illusion. Movement exists everywhere. The universe is a dance of motion layered upon motion. What makes solar systems remarkable is that they remain together throughout these journeys. Gravity acts like an invisible thread connecting every member of the family. The sun's gravity reaches far beyond the familiar planets. Its influence extends into distant regions filled with icy bodies. Far beyond Pluto lies a vast realm known as the Oort cloud. This enormous spherical shell may contain trillions of frozen objects. Many are remnants from the solar system's formation more than 4.5 billion years ago. These ancient travelers drift at the very edge of the sun's gravitational reach, and yet they remain part of our family. Even from such immense distances, the sun still holds them. It is remarkable to think that our solar system is far larger than most people imagine. The planets occupy only a tiny fraction of its true size. Beyond them stretches a kingdom of ice, darkness, and forgotten worlds. Together, they all move through the galaxy like passengers aboard a ship crossing an endless cosmic ocean. Other stars possess similar families. Astronomers have discovered thousands of planets orbiting distant suns. Some systems contain giant planets larger than Jupiter. Others contain rocky worlds smaller than Earth. Some stars host tightly packed planetary systems where multiple worlds orbit closer than Mercury does to our sun. Others possess planets traveling on vast, elongated paths that take centuries to complete. Each system is unique. Each follows its own story. Yet all share one thing in common. They travel together. A star and its companions bound by gravity, crossing the galaxy side by side. Sometimes these journeys last for billions of years. A stable star may shine long enough for continents to form on nearby planets. Oceans may appear. Atmospheres may evolve. Life may emerge. Entire histories may unfold beneath the steady light of a single sun as it continues its silent voyage through space. There is something comforting about that image. A star carrying its worlds through darkness. Planets circling faithfully around their parent sun. Moons accompanying their planets. Everything moving together. No destination, no final harbor. Just an endless journey through the galaxy. Not every system remains unchanged, however. Gravity occasionally introduces surprises. Passing stars can alter planetary orbits. Nearby encounters can disturb distant comets. Galactic tides slowly influence the outer edges of solar systems. Over immense periods of time, even stable arrangements can evolve. Yet most systems prove remarkably resilient. The bonds created by gravity are surprisingly strong. For billions of years, stars often keep their planetary families close. Astronomers believe our own sun was born within a crowded stellar nursery. Thousands of young stars likely formed nearby. For a time, the newborn sun traveled among many siblings. The night sky from early Earth might have looked very different. Bright neighboring stars may have illuminated the darkness far more strongly than today. Eventually, those siblings drifted away. Each star followed its own path around the Milky Way. The family dispersed. Today, the sun travels largely alone. Its siblings are scattered throughout the galaxy. Some may lie hundreds or thousands of light years away. Yet somewhere out there, distant stars share a common birthplace with our own. They are cosmic relatives separated by billions of years of travel. This idea transforms the Milky Way into something more personal. The galaxy is not simply a collection of unrelated stars. It is a place filled with ancient families, stars born together, traveling apart. occasionally crossing paths again after unimaginable spans of time. Even entire groups of stars sometimes move together. Astronomers have identified stellar streams, vast rivers of stars flowing through the galaxy. These streams are often the remnants of ancient clusters gradually stretched apart by gravity. Though separated by great distances, the stars continue following similar paths, like travelers who began the same journey long ago. The galaxy remembers where they came from. In a sense, the Milky Way is full of migration routes, invisible highways traced by stars and their accompanying worlds. As the solar system continues its own voyage, it occasionally passes through different regions of the galaxy. Some areas are rich in gas and dust, others are relatively empty. Over hundreds of millions of years, our cosmic surroundings slowly change. The stars visible in Earth's sky today are not the same stars that dinosaurs saw, nor are they the stars future civilizations will see. The galaxy evolves continuously, yet through all these changes, the sun keeps carrying its planetary family onward. Earth remains one of its faithful companions. For more than 4 billion years, our planet has accompanied the sun on this extraordinary journey. Together they have traveled through countless regions of the Milky Way. Together they have completed nearly 25 full orbits around the galactic center. And the journey continues. Right now, this very moment, the Earth beneath you is moving. The sun is moving. The entire solar system is moving. We are all passengers aboard a vast celestial vessel crossing the galaxy. There is no engine, no captain, only gravity guiding the way. Perhaps that is one of the most beautiful realities in astronomy. We are not standing still beneath the stars. We are traveling with them, part of a family bound together by invisible forces, carried through the darkness by a star that has watched over us for billions of years. And somewhere ahead, countless new regions of the galaxy await, silent, ancient, unseen, waiting patiently for our solar system to drift past them on its endless voyage through the cosmos. Long before a planet exists, long before oceans shimmer beneath sunlight, long before mountains rise, forests grow, or living creatures take their first breath, something else must happen first. A cloud must begin to dream. Far across the galaxy, hidden among the darkness between the stars, enormous clouds of gas and dust drift silently through space. At first glance, they may seem empty, featureless, lifeless. Yet these vast clouds are among the most important places in the universe, because within them, new worlds are constantly being built. At this very moment, while countless people sleep beneath Earth's night sky, giant cosmic clouds are slowly assembling the ingredients for future stars, future planets, and perhaps future civilizations. The process is so gradual that it unfolds over millions of years, yet it never truly stops. The galaxy is always creating, always rebuilding, always preparing the next generation of worlds. Astronomers call these immense structures molecular clouds. Some stretch across hundreds of light years. Others contain enough material to create thousands of stars. Within them are hydrogen, helium, carbon, oxygen, water molecules, and countless tiny grains of dust. These clouds may appear dark when viewed through ordinary telescopes. In fact, many are so dense that they block the light of stars behind them. To ancient skywatchers, such regions may have seemed like empty holes in the heavens. But modern astronomy has revealed something extraordinary. Those dark patches are not empty at all. They are cosmic nurseries, places where creation quietly unfolds. Inside these clouds, gravity begins its patient work. Tiny regions become slightly denser than their surroundings. Perhaps a nearby supernova sends a shockwave through the cloud. Perhaps turbulence creates a small concentration of gas. Whatever the cause, gravity notices. And once gravity takes hold, the process begins. Matter slowly gathers. Gas drifts inward. The growing clump becomes heavier. Its gravity becomes stronger. More material falls toward the center. The cycle feeds itself. Over hundreds of thousands of years, the cloud continues collapsing. What was once a faint concentration of gas gradually transforms into something remarkable. A new star is being born. The young star remains hidden at first. wrapped inside thick blankets of dust and gas. Its light struggles to escape. From the outside, little can be seen, but deep within the cloud, temperatures rise. Pressure increases. The newborn star grows brighter. Eventually, conditions become extreme enough for nuclear fusion to ignite. Hydrogen atoms begin merging into helium. Energy is released. A star awakens. For the first time, a new sun begins shining into the darkness. Yet the story does not end there. In many ways, it is only beginning. Around the young star, leftover gas and dust continue swirling. A vast rotating disk forms. Within that disk, tiny particles collide. At first, the collisions create grains no larger than sand, then pebbles, then rocks. Over time, these objects grow larger. Gravity helps them gather additional material. Countless impacts slowly build larger structures. Planetary embryos emerge. Future worlds begin taking shape. This process may sound simple, but it creates astonishing diversity. Some worlds become rocky planets like Earth. Others grow massive enough to capture thick atmospheres, becoming giants like Jupiter. Some may develop oceans, others may remain frozen. Some may orbit close to their stars, others wander in distant darkness. Each planetary system becomes unique. Each tells a different story, yet nearly all begin the same way. Inside a cloud, inside darkness, inside a place where gravity patiently gathers matter together. When astronomers observe stellar nurseries, they are witnessing these events in real time. Powerful telescopes reveal glowing nebulae scattered throughout the galaxy. These beautiful structures often shine in shades of red, pink, blue, and violet. Their colors come from energetic young stars illuminating surrounding gas. The result is breathtaking. Vast cosmic landscapes filled with pillars, filaments, and glowing clouds. But beyond their beauty lies something even more profound. These are factories of creation. Every bright region may contain hundreds or thousands of newborn stars, each one potentially surrounded by developing planets, each one perhaps destined to host future life. One of the most famous examples is the Orion Nebula. Visible even to the naked eye under dark skies, it lies about 1,300 light-years from Earth. Within it, thousands of young stars are actively forming. Some are only a few 100,000 years old. In stellar terms, they are infants. Studying Orion allows astronomers to glimpse what our own solar system may have looked like billions of years ago. Because the Sun, too, was born inside a cloud. Long before Earth existed, our star began as a collapsing pocket of gas. The atoms in your body once drifted through that ancient stellar nursery. The oxygen you breathe, the carbon in your cells, the calcium in your bones, all were part of the cloud that gave birth to the Sun. That realization carries a certain quiet beauty. You are not merely observing the universe. You are one of its creations, a product of processes that began long before Earth formed. The story becomes even more remarkable when we remember where those atoms originated. Many were forged inside older stars, stars that lived and died before the Sun existed. Their explosions enriched interstellar clouds with heavier elements. Those enriched clouds later formed new stars, new planets, eventually new life. Creation in the universe is rarely a single event. It is a chain. One generation gives rise to the next. The death of one star helps create another. The destruction of old worlds helps build new ones. Nothing is truly wasted. Everything becomes part of the next chapter. Even today, countless clouds continue this cycle. Across the Milky Way, new stars ignite every year. New planetary systems emerge. New possibilities appear. Some of those distant worlds may currently resemble the young Earth. Others may already host oceans beneath alien skies. Some may remain barren for billions of years. Others may someday support living ecosystems. No one knows for certain, but the raw materials are there. The process is underway. The clouds continue their work. Patient, silent, unstoppable. Perhaps that is one of the most comforting truths in astronomy. The universe is not running down into emptiness. It is continually renewing itself. While some stars fade and die, others are being born. While old planetary systems age, new ones emerge. The galaxy remains alive with creation. And all of it begins inside these immense drifting clouds. The next time you look into the night sky, remember that hidden among those countless stars are regions where future suns are already taking shape. Future planets are gathering from dust. Future oceans may someday sparkle beneath unfamiliar skies. Future beings may one day look upward and wonder about their origins. All because somewhere in the darkness, a cloud quietly continued building a new world. And tonight, as the galaxy turns slowly around us, those cosmic clouds are still working, patiently gathering gas, patiently shaping stars, patiently preparing the next generation of worlds that will one day shine beneath the endless sky. Imagine looking upward and seeing rings larger than any moon stretching from horizon to horizon. Not a faint band of light, not a distant object hanging quietly in the darkness, but enormous glowing arches spanning the entire sky, from one horizon to the other. A permanent celestial structure so vast that it would dominate every sunrise, every sunset, and every night. On Earth, our moon shapes poetry, calendars, myths, and dreams. But on certain worlds, the sky itself may be ruled by something far grander: the giant rings of a nearby planet. Tonight, as you settle comfortably beneath the stars, imagine standing on the surface of such a world. A peaceful place orbiting a distant sun, a world where rings never disappear, where every glance upward reveals a masterpiece of cosmic architecture. Saturn offers us a glimpse of what such a sky might look like. Its rings are among the most beautiful structures in our solar system. Though they appear solid from afar, they are actually composed of countless particles of ice and rock. Some are as small as grains of dust, others are as large as mountains. Together, they form enormous bands stretching hundreds of thousands of kilometers across space. If Earth possessed rings like Saturn's, our sky would look completely different. During the day, brilliant arcs would shine overhead. At night, the rings would reflect sunlight and create glowing ribbons across the heavens. The familiar constellations might appear framed by immense silver curves. Even moonlight would feel different. The sky would never truly be empty. Yet Saturn itself is not the only ringed world. Jupiter possesses rings. Uranus possesses rings. Neptune possesses rings. Many planets throughout our galaxy may also wear similar cosmic ornaments. Some could possess ring systems far larger and more dramatic than anything found in our own solar system. Astronomers have even discovered evidence suggesting that certain distant exoplanets may host colossal ring structures. One candidate appears to possess rings hundreds of times larger than Saturn's. If confirmed, such a system would be almost impossible to comprehend. The rings could stretch across tens of millions of kilometers. Entire worlds might exist within them. Moons could cast shadows upon them. And from the surface of nearby planets, the sky could become a living work of art. Imagine waking every morning beneath those vast celestial bands. The changing angle of the sun would paint different colors across the rings throughout the day. Sometimes they might glow white and brilliant. At other times, they could appear golden, amber, or pale blue. Their shadows might drift slowly across the landscape like enormous curtains moving through the sky. Seasons would create even greater transformations. As the planet orbited its star, the angle of the rings could shift. Certain years might bring spectacular displays. Others might cause the rings to narrow into thin, luminous lines. Entire cultures living beneath such skies would likely build stories around them. Just as humanity has long looked toward the moon for inspiration, civilizations beneath giant rings might see them as symbols of eternity. Children would grow up believing such skies are normal. Artists would paint them. Poets would celebrate them. Travelers would navigate by them. Generations might pass while the rings remain unchanged overhead. Yet these beautiful structures are surprisingly delicate. Most rings are thought to be temporary on cosmic timescales. They may form when moons collide, when comets break apart, or when wandering objects are torn apart by powerful gravitational forces. Over millions of years, ring particles gradually spread outward or fall inward. The magnificent displays eventually fade. New rings may emerge, old rings may disappear. Even the grandest structures in the universe are not permanent. That realization makes them even more beautiful. Some moons orbit within ring systems themselves. These small worlds act like cosmic shepherds. Their gravity helps shape the rings into narrow bands and intricate patterns. As they travel through space, they carve gaps and channels through the surrounding material. The result is a constantly evolving dance between moons and rings, a silent choreography unfolding across unimaginable distances. From afar, the rings appear peaceful, but within them, countless particles move continuously. Tiny collisions occur every moment. Ice fragments tumble through space. Dust drifts slowly between larger chunks of material. Everything is in motion. Everything is connected. And yet, from the surface of a nearby planet, it would all appear calm. A reminder that many of the universe's most dynamic processes unfold with extraordinary patience. Scientists believe rings may play important roles in the formation of planetary systems. The young solar system itself once contained enormous disks of gas and dust surrounding the newborn sun. Within those swirling structures, particles collided and combined. Gradually, planets emerged, moons formed, asteroids developed, entire worlds took shape. In a way, modern ring systems may offer glimpses of processes that helped build planets billions of years ago. They are not merely decorations. They are echoes of creation, fragments of stories that began long before Earth existed. Perhaps somewhere tonight, on a distant world orbiting an unfamiliar star, a peaceful ocean reflects the glow of giant rings overhead. Gentle waves shimmer beneath silver arches stretching across the heavens. A cool breeze moves through alien forests. Mountains cast long shadows beneath a sky unlike anything humanity has ever witnessed. And somewhere on that world, life may look upward with the same curiosity that guides us here on Earth, wondering about the universe, wondering about distant stars, wondering whether other beings exist beneath other skies. The cosmos is filled with possibilities far stranger than imagination once allowed. Worlds with multiple suns, worlds where daylight lasts for years, worlds wandering through darkness without any star at all, and perhaps worlds crowned by magnificent rings so vast they transform the entire sky into a celestial masterpiece. As we continue our gentle journey through the universe tonight, allow yourself to picture those distant horizons. Imagine standing quietly beneath immense glowing arcs. Imagine the peaceful silence, the endless sky, the slow movement of cosmic structures older than civilizations. There is something comforting about knowing that such beauty may exist somewhere beyond our reach. Not because we can visit it, but because it reminds us how vast the universe truly is. Every star above may illuminate worlds we have never seen. Every point of light may possess its own wonders, its own stories, its own skies, and somewhere among them, giant rings may still be shining softly across alien heavens, stretching from horizon to horizon, waiting beneath the patient light of distant suns. Tell me in the comments which cosmic world you would most like to visit while drifting peacefully through space tonight. There are places where entire clouds glow in colors invisible to human eyes. Most of us think of the night sky as dark, a black canvas sprinkled with stars, a quiet backdrop for sleep, dreams, and distant thoughts. But the universe is not truly dark at all. Beyond the limits of human vision, space is alive with light. Invisible rivers of color flow through giant clouds of gas. Radiation dances across entire galaxies. Charged particles collide in silent explosions of energy, and enormous cosmic structures glow continuously, painting the universe with colors our eyes were never designed to see. Tonight, as you settle comfortably beneath the stars, imagine being able to see every wavelength of light. Imagine removing the limits of human vision. Suddenly, the universe would transform into something far stranger and more beautiful than anything you have ever imagined. The familiar stars would remain, but around them, vast hidden landscapes of light would appear. Gigantic nebulae would glow like floating lanterns. Galaxies would shimmer with invisible energy. Even the darkness between the stars would reveal delicate structures stretching across unimaginable distances. One of the most spectacular examples can be found inside stellar nurseries. These enormous clouds of gas and dust are the birthplaces of stars. To our eyes, they may appear faint or colorless, but viewed through specialized instruments, they become radiant masterpieces. Hydrogen gas often glows deep red. Oxygen can shine with emerald green hues. Sulfur may appear golden or orange. Together, they create breathtaking combinations of color that resemble cosmic paintings suspended in space. The famous Orion Nebula is one such place. Visible even without a telescope under dark skies, it appears as a faint patch of light. Yet when astronomers capture it using long exposures and scientific filters, an entirely different universe emerges. Immense curtains of glowing gas twist through space. Brilliant newborn stars illuminate their surroundings. Dark clouds weave intricate shadows across luminous backgrounds. It becomes less like a cloud and more like a living work of art. And Orion is only one example among countless others. Throughout the Milky Way, similar structures quietly shine. Some stretch for dozens of light years, others span hundreds. Within them, gravity slowly gathers material into future suns. New planetary systems begin to take shape. Entire generations of stars are born amid glowing oceans of gas. Yet visible light represents only a tiny fraction of reality. Beyond red lies infrared light. Beyond violet lies ultraviolet. Farther still are X-rays, gamma rays, and radio waves. Each reveals a completely different version of the universe. If your eyes could detect infrared light, the night sky would look dramatically different. Cool clouds of dust would glow softly against the darkness. Hidden structures inside nebulae would become visible. Regions that appear empty would reveal delicate filaments stretching across space. Astronomers often use infrared telescopes to peer through cosmic dust, because infrared light can pass through obstacles that block ordinary visible light. It allows us to see regions of the cosmos normally concealed from view. In many ways, infrared astronomy is like gaining a new sense, a new way of experiencing reality. Meanwhile, ultraviolet light reveals some of the hottest and most energetic objects in existence. Young, massive stars blaze intensely in ultraviolet wavelengths. Entire star clusters radiate energy invisible to human eyes. Viewed in ultraviolet, galaxies become landscapes of brilliant stellar activity. Regions of intense star formation glow like cosmic campfires scattered across the darkness. And then there are X-rays. The universe seen in X-rays is astonishing. Black holes become visible. Neutron stars shine fiercely. Superheated gas trapped inside galaxy clusters radiates enormous amounts of energy. Explosions from dying stars leave glowing remnants that can persist for thousands of years. To an X-ray telescope, space appears alive with violent beauty. A hidden universe of extreme temperatures and powerful forces. Yet perhaps some of the most enchanting natural light shows occur much closer to home. Earth itself hosts extraordinary displays. The auroras that dance above polar regions are among nature's greatest spectacles. When charged particles from the sun collide with Earth's atmosphere, they create shimmering curtains of green, red, violet, and blue light. These luminous waves ripple silently across the sky. Ancient cultures often viewed them as messages from spirits or gods. Today we understand their scientific cause, yet knowing the explanation does nothing to diminish their beauty. If anything, understanding the physics makes them even more remarkable, because those glowing curtains are evidence of a connection stretching all the way from the sun to our planet. A cosmic interaction visible to the naked eye. Other worlds experience auroras too. Jupiter possesses auroras far more powerful than Earth's. Saturn glows with its own polar lights. Even distant planets may host spectacular displays generated by powerful magnetic fields and energetic particles. Imagine standing beneath an alien sky illuminated by auroras hundreds of times brighter than anything on Earth. Waves of light flowing endlessly overhead, colors shifting and swirling through the darkness. The universe may contain countless such wonders. Some of the most astonishing light shows occur when stars die. A supernova explosion can briefly outshine an entire galaxy. For weeks or months, a single dying star may radiate more energy than billions of suns combined. Across immense distances, the explosion becomes visible as a brilliant beacon. The expanding shockwave races outward through space. Elements forged inside the star scatter into surrounding regions. Future planets and future life may eventually emerge from those materials. Even destruction creates beauty. Even endings become beginnings. Long after the explosion fades, glowing remnants remain. Delicate filaments expand through space. Colorful clouds continue shining. Astronomers observe these structures centuries after the original star vanished. Ghostly monuments marking one of nature's most powerful events. And beyond individual stars lie entire galaxies glowing in ways we can scarcely imagine. Some galaxies radiate strongly in radio wavelengths. Others blaze brightly in infrared light. Some harbor active black holes that release enormous jets of energy stretching thousands of light years into space. Viewed across the full electromagnetic spectrum, galaxies become dynamic ecosystems of light. Complex, beautiful, alive with motion and energy. The truth is that human vision captures only a tiny glimpse of reality. Our eyes evolved to detect the narrow range of wavelengths most useful for survival on Earth. But the universe operates across a much broader canvas. The colors we see are merely a small window into an endless spectrum. And perhaps there is something comforting in that realization, knowing that there is always more to discover, more beauty hidden beyond the limits of perception, more wonders waiting in regions we cannot yet fully explore. As you continue this peaceful journey through the cosmos tonight, imagine drifting silently above the galaxy, far from planets, far from cities, far from every familiar light. Around you stretch immense glowing clouds. Invisible colors fill the darkness. Stars ignite inside radiant nebulae. Galaxies shimmer like distant lanterns. Auroras dance across alien skies. Ancient starlight travels across millions of years to reach unseen destinations. Everywhere, the universe is creating natural light shows beyond imagination. Not for an audience, not for applause, simply because that is what the cosmos does. It creates beauty on scales both vast and subtle. And tonight, beneath the quiet glow of your own sky, you are part of that beauty too. A small observer drifting through a universe filled with hidden colors, endless light, and wonders that continue shining whether anyone sees them or not. Certain stars race through the Milky Way so quickly that they can eventually escape the galaxy itself. When we look at the night sky, the stars appear calm, fixed, patient, almost eternal. Night after night, they seem to occupy the same positions, quietly watching over the world below. It is easy to imagine that the heavens are still, that stars simply hang in place while planets circle around them. But the reality is very different. Every star you see tonight is moving. Some drift slowly through the galaxy, others orbit peacefully around the Milky Way's center, and a rare few are traveling so fast that they may one day leave the galaxy forever. These are among the greatest wanderers in the universe, the runaway stars, the hypervelocity stars, cosmic travelers racing through the darkness at speeds almost beyond imagination. Tonight, as you settle comfortably beneath the stars, imagine standing aboard an impossible spacecraft, one capable of following these stellar travelers wherever they go. Far beyond familiar constellations, far beyond the spiral arms of our galaxy, into regions few stars will ever visit. Most stars travel through the Milky Way at speeds of hundreds of thousands of kilometers per hour. Even our own sun is moving. As Earth circles the sun itself circles the center of the Milky Way. Together, our entire solar system travels through space at roughly 828,000 kilometers per hour. It feels astonishing. Yet compared to some stars, even that is relatively modest. Certain stars move several times faster. Some exceed 1,000,000 kilometers per hour. Others move faster still. The most extreme examples can reach speeds exceeding 2 million kilometers per hour, fast enough to eventually break free from the gravitational grip of the Milky Way itself. Imagine what such a journey would look like. For billions of years, a star may live among countless neighbors, surrounded by stellar companions, embedded within the glowing structure of a spiral galaxy. Then, suddenly, something changes. A powerful gravitational encounter occurs. The star receives an enormous cosmic push, and it begins a journey toward the emptiness between galaxies, never to return. One of the most fascinating mechanisms behind these stellar escapes involves black holes. At the center of our galaxy resides a supermassive black hole known as Sagittarius A star. Containing millions of times the mass of our Sun, it exerts an extraordinary gravitational influence on nearby stars. Occasionally, a binary star system ventures too close. Two stars orbiting one another enter the black hole's domain. Gravity begins to pull on them with tremendous force. One star may be captured, the other can be flung outward like a stone released from a sling. The result is a hypervelocity star, a stellar refugee launched across the galaxy at incredible speed. Astronomers believe this process has created many of the fastest stars ever discovered. These stars become living evidence of interactions with one of the most powerful objects in existence. Every kilometer they travel tells a story about gravity operating at its most extreme. Some runaway stars are created differently. Massive stars often form in crowded clusters. Hundreds or thousands of young suns may share the same stellar nursery. Within these dense environments, gravitational encounters occur constantly. Stars tug on one another. Orbits shift. Companions exchange places. Over time, chaos can build. Sometimes a close encounter launches one star outward at tremendous speed, like a cosmic pinball ricocheting through the galaxy. Other runaway stars are born from supernova explosions. Imagine two stars orbiting one another for millions of years. One eventually grows old and explodes. The blast destroys the delicate gravitational balance. The surviving companion suddenly finds itself released. No longer held in place by its partner's gravity, it continues racing through space alone. A traveler set free by catastrophe. These runaway stars carry remarkable histories. Their motions preserve evidence of ancient events long after the original explosions have faded. Astronomers can often trace their paths backward through space, like detectives reconstructing a mystery. By studying their trajectories, scientists identify the clusters where they formed, the supernova remnants they once orbited, or the black holes that altered their destinies. In this way, stars become storytellers, their movements recording chapters of galactic history. Some of these stellar travelers may carry planets with them. This possibility is especially fascinating. If a runaway star possessed a planetary system before being accelerated, some planets could potentially survive the journey. Imagine living on such a world. Your sun would be racing through the galaxy at extraordinary speed. The night sky would slowly transform over millions of years. Constellations would shift. Neighboring stars would change. Entire regions of the galaxy would come and go. Eventually, your planetary system might even leave the Milky Way altogether, crossing into intergalactic space, a place where the darkness between galaxies stretches for millions of light years. There, the sky would become profoundly different. The Milky Way itself would shrink behind you, magnificent spiral island of light, growing smaller with every passing age. Other galaxies would shine faintly in the distance. The universe would feel even larger, even quieter, even more mysterious. Fortunately, our own sun is not moving nearly fast enough to escape the Milky Way. It remains comfortably bound to the galaxy's gravitational embrace. For billions of years, it will continue its slow journey around the galactic center, completing one orbit approximately every 225 million years. The dinosaurs lived during a different phase of this galactic voyage. Future civilizations, if they arise, will inherit a different position within the Milky Way. Everything is moving. Everything is changing. Only the timescales make the motion difficult to notice. In many ways, stars are like travelers crossing an immense ocean. Some remain close to home. Some follow familiar routes. Others embark on extraordinary journeys into unknown waters. Yet all are carried by the currents of gravity, invisible forces shaping their destinies across billions of years. Perhaps there is something comforting in that thought. The universe is not frozen. It is alive with motion. Galaxies rotate, stars migrate, planets orbit. Even the atoms within your body are constantly moving. Stillness is often an illusion, created by limited perspective. On cosmic timescales, everything dances, everything flows, everything travels. As we continue our peaceful journey tonight, imagine one of these runaway stars gliding silently through the darkness, its light shining steadily. Its planets, if any exist, faithfully following behind. Ahead lies an endless voyage through space. Behind lies a galaxy slowly fading into the distance. No destination, no finish line. Only motion, only time. Only the quiet persistence of a star continuing its journey across the universe. Somewhere tonight, beyond the constellations we know, such travelers are already crossing the Milky Way, moving through darkness older than humanity, carrying their light into regions few stars will ever reach. And perhaps that is one of the most beautiful truths in astronomy. Even stars can become explorers. Even suns can wander. And the universe itself is far larger, far more dynamic, and far more adventurous than the night sky first appears. Most of the universe cannot be seen, touched, or photographed directly, yet it shapes everything around us. Imagine walking through a vast forest at night. The trees surround you. The ground supports your steps. A gentle wind moves unseen through the leaves. You cannot see the wind itself, yet you know it is there because of its effects. The branches sway, the leaves rustle. The air brushes softly against your skin. Now imagine something similar happening across the entire universe, something invisible, something that neither shines nor reflects light, something that cannot be photographed directly, yet something whose presence can be detected everywhere we look. Tonight, as you settle comfortably beneath the stars, we are going to explore one of the greatest mysteries in modern astronomy, a hidden substance that may make up most of the matter in the cosmos, a substance known as dark matter. Despite its name, dark matter is not simply ordinary matter hiding in darkness. It appears to be something entirely different, a mysterious form of matter that does not interact with light in the ways we understand. No telescope can see it directly. No camera can capture its appearance. Yet without it, galaxies as we know them might not exist at all. The story begins with a simple question. Why do galaxies stay together? At first glance, the answer seems obvious. Gravity. Stars attract one another. Galaxies contain enormous amounts of mass. That mass generates gravity. Gravity holds everything in place. Simple. At least, that is what astronomers once believed. But as scientists began measuring the motions of stars inside galaxies, they discovered something unexpected. The outer stars were moving far too quickly. According to the visible matter present, those stars should have been flung into intergalactic space long ago. Imagine spinning a merry-go-round. The faster it spins, the harder it becomes for riders near the edge to hold on. The same principle applies to galaxies. Stars orbiting far from the center should move more slowly. Yet observations revealed that many of them travel astonishingly fast. Something unseen seemed to be providing additional gravity. Something hidden was helping hold galaxies together. This discovery transformed astronomy. It suggested that the stars, planets, gas clouds, and nebulae we can see represent only a small fraction of what actually exists. The visible universe might merely be the tip of an enormous cosmic iceberg. Everything familiar, every star, every planet, every moon, every mountain, every ocean, every living creature may account for only a tiny portion of the universe's total matter. The rest remains hidden. To understand this strange idea, imagine looking at a city at night from high above. You see streetlights, buildings, traffic, windows glowing in the darkness. Those lights reveal where people live and work, but they do not show everything. The roads themselves may be difficult to see. Parks vanish into darkness. Rivers become nearly invisible. The city is much larger than the lights alone suggest. In a similar way, stars illuminate only part of the cosmos. The visible structures we observe may simply trace a much larger invisible framework. Astronomers now believe galaxies are embedded within enormous halos of dark matter. These halos extend far beyond the visible stars, in some cases several times farther. The Milky Way itself may sit inside a vast sphere of dark matter, stretching hundreds of thousands of light years into space. Though invisible, this hidden mass exerts gravity continuously. It influences the motion of stars. It guides the formation of galaxies. It shapes the architecture of the universe itself. Without dark matter, many galaxies might never have formed. In the early universe, shortly after the Big Bang, matter was distributed more evenly than it is today. Over time, gravity pulled material together. Small clumps grew larger. Larger structures attracted more matter. eventually galaxies emerged. Dark matter appears to have acted as an invisible scaffold during this process. Its gravity helped gather ordinary matter into the structures we see today. In a sense, galaxies may have grown upon foundations we cannot directly observe, like castles built upon hidden bedrock beneath the ground. One of the most remarkable pieces of evidence comes from something called gravitational lensing. According to Einstein's theory of relativity, massive objects bend space-time. As light travels through that curved space-time, its path changes. Galaxies and clusters of galaxies can act like enormous lenses. They bend and distort the light from objects behind them. Astronomers can measure these distortions. By doing so, they calculate how much mass must be present. Again and again, the results reveal far more mass than visible matter can explain. The invisible component appears everywhere, quietly shaping the universe from behind the scenes. Entire clusters of galaxies provide additional clues. These colossal structures contain hundreds or even thousands of galaxies bound together by gravity. When scientists measure their motions, the same mystery emerges. There is simply not enough visible matter to account for what is happening. Something hidden contributes most of the gravitational pull. Something unseen surrounds and permeates these cosmic giants. Yet despite decades of research, dark matter remains elusive. Scientists do not know exactly what it is. It does not appear to be made of atoms like ordinary matter. It may consist of entirely new particles never yet detected. Around the world, enormous experiments search for answers. Sensitive detectors operate deep underground. Powerful particle accelerators probe fundamental physics. Space telescopes study the structure of the cosmos. Each investigation brings us closer to understanding one of nature's deepest secrets. And perhaps that mystery is part of what makes the universe so fascinating. Even after centuries of scientific progress, enormous questions remain. We have mapped planets, explored moons, photographed black holes, detected gravitational waves, yet most of the matter in the universe may still be unknown. There is something wonderfully humbling about that realization. The cosmos continues to surprise us, continues to challenge our assumptions, continues to reveal that reality is often stranger than imagination. As you continue drifting through this peaceful journey tonight, imagine the Milky Way floating silently in the darkness. Hundreds of billions of stars glow across its spiral arms. Nebulae shimmer softly between them. Star clusters sparkle like distant jewels. Yet surrounding everything lies an enormous invisible structure, a vast halo extending far beyond what any eye could see. Silent, hidden, powerful, holding the galaxy together through the patient force of gravity. You cannot see it, you cannot touch it, but its influence stretches across cosmic distances, like an unseen current guiding an entire ocean. And perhaps that is one of the most beautiful lessons the universe offers. Not everything important is visible. Some of the greatest forces work quietly. Some of the most profound realities remain hidden. The stars may capture our attention, but behind their light stands an invisible framework shaping the destiny of galaxies. A reminder that the universe is deeper than appearances, larger than perception, and still filled with mysteries waiting patiently in the dark. Future astronomers may look up at the night sky and see something completely unfamiliar. The constellations that seem so permanent to us tonight are not truly fixed at all. Orion, the Big Dipper, Scorpius, Cassiopeia, and every other pattern we recognize exist only because we happen to live during a particular moment in cosmic history. The stars are moving, slowly, silently, and relentlessly. Every star in the sky is traveling through the galaxy on its own journey. The changes are so gradual that a human lifetime is far too short to notice them. Yet given enough time, the familiar pictures traced across the heavens will dissolve like shapes drawn in drifting clouds. If you could travel tens of thousands of years into the future and look back at the night sky, you might not recognize it at all. Tonight, Orion stands proudly above many winter horizons. Its bright belt stars form one of the most recognizable patterns in the world. Ancient civilizations saw it, modern astronomers see it. Millions of people have looked up and found comfort in its familiar shape. But Orion is temporary. The stars that create Orion are not traveling together through space. they only appear grouped from our perspective on Earth. In reality, each star moves independently, crossing the galaxy at its own speed and in its own direction. Over tens of thousands of years, the famous hunter will slowly stretch apart. Its shoulders will shift, its belt will distort, its outline will fade. Eventually, future skywatchers may never know Orion existed. The same fate awaits every constellation. Constellations feel timeless because human history is brief. Compared to the lifespan of stars, entire civilizations pass in the blink of an eye. The pyramids of Egypt are ancient to us. The Roman Empire feels distant. Recorded human history stretches back only a few thousand years. Yet many stars have been shining for hundreds of millions or even billions of years. From their perspective, humanity has appeared almost instantly. And while we watch the stars continue moving through the galaxy without pause. Astronomers can actually measure these motions. This phenomenon is called proper motion. With precise instruments, scientists observe stars shifting tiny amounts across the sky, year after year. The movement is incredibly small, but over long periods, it accumulates. Imagine taking a photograph of the night sky tonight, then taking another photograph 50,000 years later. The differences would be astonishing. Some stars would have shifted dramatically, others would have vanished from view entirely. New stars would appear where none were visible before. The sky itself would become a different landscape. One of the most dramatic examples is a star called Arcturus. Arcturus moves so quickly relative to our position that astronomers can easily measure its motion across the sky. Thousands of years ago, it occupied a noticeably different position than it does today. Thousands of years from now, it will be somewhere else entirely. The same is true for countless other stars. The celestial map is constantly being redrawn. We simply live too briefly to watch the process unfold with our own eyes. Future humans may inherit skies filled with unfamiliar patterns. They might create entirely new constellations, new stories, new myths, new legends. Children thousands of generations from now could look upward and learn completely different star shapes than those we know today. The sky that guided sailors, inspired poets, and fascinated astronomers throughout human history is not permanent. It is merely the current version of a continually evolving masterpiece. Even the North Star will eventually change. Today, Polaris serves as Earth's famous northern guide star. Travelers have relied on it for centuries because it remains positioned almost directly above Earth's northern rotational axis. But Earth's axis slowly wobbles over time in a process called precession. The cycle takes roughly 26,000 years to complete. As the planet's orientation gradually shifts, different stars take turns becoming the North Star. Thousands of years ago, Polaris was not the pole star. Thousands of years from now, it will lose that title once again. Future navigators may steer by entirely different stars. Even our planet's relationship with the sky is constantly evolving. And then there is the larger story unfolding across the galaxy itself. The Milky Way is not standing still. Every star, including our sun, is orbiting the galactic center. Our solar system travels through the galaxy at approximately 220 kilometers per second. That sounds impossibly fast. Yet even at that speed, one complete orbit around the Milky Way takes roughly 230 million years. The dinosaurs lived during a completely different galactic season than we do. When Tyrannosaurus Rex walked across Earth, our solar system occupied another region of the galaxy. The stars surrounding the night sky were different. The cosmic neighborhood was different. The galaxy itself was different. Future astronomers will inherit their own galactic perspective, just as we inherited ours. And beyond the Milky Way, even larger changes await. The night sky currently includes distant galaxies visible through telescopes. Among them shines the Andromeda Galaxy, our nearest large galactic neighbor. Though it appears calm and motionless, Andromeda is moving toward us. Slowly but inevitably, the Milky Way and Andromeda are approaching each other. The collision will not happen for billions of years. Humanity's entire recorded history occupies only a tiny fraction of that timescale. Yet someday, far in the future, observers may witness a sky transformed by the approaching giant galaxy. As the two galaxies draw closer, Andromeda will grow larger and brighter in the heavens. Eventually, it may stretch across huge portions of the sky. future civilizations could witness a cosmic spectacle unlike anything visible today. The familiar darkness between galaxies will fill with streams of stars, glowing clouds, and immense celestial structures. The future sky may become more beautiful than anything we currently know. Perhaps the most fascinating thought is that future astronomers will experience the same sense of wonder we feel tonight. They will stand beneath unfamiliar constellations. They will ask questions about distant stars. They will wonder where they fit within the vast universe. And they may look back through ancient records to discover the skies that once belonged to us. They may learn that long ago, humans watched Orion rise above winter nights, that Polaris guided travelers north, that the Milky Way stretched overhead in patterns different from their own. To them, our sky may feel as ancient and mysterious as prehistoric landscapes feel to us. The heavens preserve no permanent shape. Everything changes. Stars move, galaxies evolve, orbits shift, light travels onward. Yet there is something comforting about this constant transformation. The universe does not stand still. It grows, changes, and reinvents itself across unimaginable spans of time. Tonight's sky is only one chapter in a story that has been unfolding for billions of years. And long after we are gone, future astronomers will continue turning its pages beneath constellations we have never seen. On some planets, the movement of light across the sky is so slow that dawn can stretch longer than an entire vacation on Earth. Imagine waking up just before sunrise. The horizon glows faintly with shades of deep orange and soft gold. A thin line of light appears in the distance. You expect the sun to rise within minutes, just as it does on Earth, but it doesn't. An hour passes, then another. The sunlight climbs only slightly higher. The colors continue shifting across the sky, moving almost imperceptibly. A full day goes by. The sunrise is still happening. Another day passes. The dawn continues. On some worlds scattered throughout the cosmos, mornings can last not for minutes, but for days, weeks, or even months. The familiar rhythm of sunrise and sunset that shapes life on Earth is not a universal rule. It is simply one possibility among countless others. Tonight, as we drift peacefully through the universe, let's visit these extraordinary worlds where daylight moves with astonishing patience, and where dawn itself becomes a long and beautiful event. Here on Earth, we rarely think about how fortunate we are to experience a balanced cycle of day and night. Our planet rotates once every 24 hours. This steady spin creates predictable sunrises, afternoons, sunsets, and nights. Life has adapted to this rhythm for billions of years. Plants open their leaves to morning sunlight. Animals follow daily schedules. Human civilizations build entire cultures around the rising and setting of the sun. But not every planet rotates as quickly as Earth. Some worlds turn much more slowly. On these planets, a single day can last weeks, months, or even longer. Imagine standing on such a world. The sun would appear to creep across the sky at an almost unbelievable pace. Hours would pass with barely noticeable movement. The changing angle of sunlight would become a slow-motion performance, unfolding across enormous stretches of time. A sunrise might linger for days. Shadows would stretch gradually across the landscape. Colors would shift so slowly that the transformation might feel almost magical. One fascinating example exists within our own solar system. Mercury, the innermost planet, rotates extremely slowly. Although Mercury circles the sun every 88 Earth days, its rotation produces a solar day lasting approximately 176 Earth days. If you could stand safely on Mercury's surface, protected from its extreme temperatures, you would witness a sky unlike anything experienced on Earth. The sun would crawl across the heavens with extraordinary slowness. In some regions, it would even appear to stop, reverse direction briefly, and then continue its journey. Sunrise on Mercury is not a quick event. It is an epic passage of light unfolding over many Earth days. The landscape would remain bathed in extended dawn colors for astonishing lengths of time. Even stranger worlds exist beyond our solar system. Many exoplanets orbit extremely close to their stars. The powerful gravitational pull from their suns can lock them into a condition known as tidal locking. This means one side of the planet permanently faces the star, while the other side remains turned away. One hemisphere experiences endless day, the opposite hemisphere experiences endless night. For an observer living exactly between these regions, near the boundary often called the terminator zone, the sun might hover near the horizon indefinitely. There may be no true sunrise or sunset at all. Instead, the sky could remain frozen in a permanent state of dawn or twilight. Imagine a landscape illuminated by an eternal sunrise, soft golden light stretching endlessly across mountains and valleys, long shadows that never change, a sky forever suspended between day and night. Such places may exist right now, somewhere within our galaxy. On Earth, dawn is often associated with beginnings. It marks the start of a new day. Birds begin singing, temperatures rise, the world awakens. But on a slowly rotating planet, these transitions would unfold at an entirely different pace. Temperatures could change gradually over weeks. Winds might evolve slowly as sunlight creeps across the terrain. Entire weather systems could develop during a single sunrise. The atmosphere itself might respond to dawn like a living thing awakening in slow motion. Imagine watching frost slowly melt over several days, cloud formations drifting through extended golden light, mountains casting shadows that move only a few meters over many hours. The entire world would seem to breathe more slowly. Time itself might feel different. If intelligent life evolved on such a planet, their experience of time could be profoundly unlike ours. Their calendars, cultures, and daily routines might adapt to cycles far longer than 24 hours. Perhaps they would celebrate the arrival of dawn as a major event. Perhaps entire festivals would take place during a sunrise, lasting weeks. Stories, traditions, and architecture might all be shaped by the slow movement of light. For them, our rapid Earth sunrises could seem astonishingly brief, just as their endless dawns seem extraordinary to us. Astronomers have discovered thousands of exoplanets over the past few decades. These discoveries reveal an incredible truth. The universe is far more diverse than we once imagined. Some planets are larger than Jupiter, others are smaller than Earth. Some orbit multiple stars, some travel through space without any star at all. Some may possess oceans beneath thick layers of ice. Others may have skies filled with clouds made of minerals or vaporized metals. In such a universe, it should not surprise us that some worlds experience dawns unlike anything known on Earth. Every new discovery expands our understanding of what a planet can be, and perhaps what life itself can become. There is something deeply calming about imagining a sunrise that lasts for days. On Earth, we often rush through our mornings. Minutes feel precious. Schedules begin, responsibilities return. The day accelerates almost immediately. But on these distant worlds, dawn unfolds patiently. Light arrives gently. The sky changes slowly. There is no hurry, no urgency, only a gradual transition from darkness into brightness. Perhaps that is one reason these cosmic landscapes capture our imagination. They offer a vision of time moving differently. A reminder that not every corner of the universe follows the pace we know. Some places operate according to rhythms almost impossible to experience here on Earth. As you continue relaxing beneath the stars tonight, imagine yourself standing on one of these distant planets. The horizon glows softly. Golden light spreads across a silent landscape. Mountains shimmer beneath an endless dawn. The sun rises so slowly that hours feel like moments. Days pass while the sky continues brightening. There is nowhere to rush, nothing demanding your attention. Only the gentle movement of light across an alien world. Somewhere among the hundreds of billions of stars in our galaxy, such a sunrise may be happening right now. A dawn lasting longer than an entire vacation on Earth. A reminder that the universe contains wonders stranger, larger, and more beautiful than we often imagine. If this journey is helping you relax, don't forget to like the video so more curious minds can discover the wonders of the universe. Before becoming part of you, many of your atoms spent billions of years wandering through ancient stars and galaxies. Take a moment and look at your hands. The skin, the bones beneath it, the blood quietly flowing through your veins. Everything feels familiar, personal, close. It is easy to think that your body belongs entirely to Earth. But the truth is far more extraordinary. The atoms that make you were not born here. long before Earth existed, long before the sun began to shine, long before oceans formed or continents emerged. The tiny particles that would eventually become part of you were already traveling through the universe. Tonight, as we continue our peaceful journey among the stars, imagine following the path of a single atom. A journey so vast that it stretches across billions of years. A journey that begins before our planet was even a possibility. The universe started with remarkable simplicity. Shortly after the Big Bang, space contained mostly hydrogen and helium. There were no rocky planets, no oceans, no trees, no animals, no people. The elements needed for life simply did not exist yet. Carbon was absent, oxygen was absent, iron was absent. The universe was young and chemically simple, but gravity was already at work. Slowly, enormous clouds of hydrogen gathered together. As they collapsed under their own weight, the first stars ignited. These ancient stars became the universe's first great factories. Deep inside their blazing cores, nuclear fusion began transforming simple elements into more complex ones. Hydrogen became helium. Helium became carbon. Carbon eventually helped create oxygen and other heavier elements. For the first time, the ingredients of life were being forged. Every atom of carbon inside your body may have spent millions of years inside one of these ancient stellar furnaces. Imagine being a tiny carbon atom born in the heart of a giant star. For millions of years, you remain trapped within an ocean of plasma, hotter than anything found on Earth. Around you, nuclear reactions rage continuously. Light struggles to escape. Pressure reaches unimaginable levels. Then one day, everything changes. The star dies. Some stars end their lives in explosions so powerful that they briefly outshine entire galaxies. These events, known as supernovae, scatter newly created elements across space. The carbon atom begins a new journey. It is thrown outward into the darkness, no longer trapped inside a star. Now it drifts freely among the stars for millions of years, then hundreds of millions, then perhaps billions. The universe is patient. Space is vast. An atom can wander for unimaginable lengths of time before finding a new home. Eventually, clouds of gas and dust begin gathering again. These clouds contain the recycled remains of earlier generations of stars, fragments of ancient suns mixed together like ingredients in a cosmic recipe. Within one such cloud, about 4.6 billion years ago, our own solar system began to form. The sun ignited at the center. Around it, planets slowly emerged. Dust grains collided. Small rocks became larger rocks. Larger rocks became worlds. Some of the atoms that had traveled across interstellar space eventually became part of Earth. The iron deep within our planet, the oxygen in the atmosphere, the silicon in rocks, the calcium in future bones. All of it carried a history older than the world itself. The Earth was not built from new material. It was assembled from ancient stardust. Even today, traces of that history remain hidden within every living thing. The oxygen you breathe was forged inside stars. The calcium in your teeth was created in stellar interiors. The iron flowing through your blood once existed within exploding suns. When astronomers say that we are made of stardust, they are not speaking poetically. They are describing a literal scientific reality. Your body is a collection of atoms that have traveled farther than any spacecraft humanity has ever launched. Some of those atoms may have crossed entire regions of the Milky Way. Some may have passed through multiple generations of stars before eventually becoming part of Earth. Think about that for a moment. An atom currently sitting in your fingertip may be older than our sun, older than our planet, older than the oceans. Its story stretches backward through cosmic history, far beyond anything human civilization can remember. And the journey does not end with you. The atoms within your body are only temporary visitors. Throughout your life, you constantly exchange matter with the world around you. Every breath brings new atoms into your lungs. Every meal introduces atoms that once existed in plants, animals, oceans, and soil. The atoms that make up your body today are not exactly the same ones that were there years ago. Matter is always moving, always changing, always traveling. The universe never truly stands still. One day, far in the future, The atoms that currently belong to you will continue their journey. Some will return to the atmosphere. Some will become part of new plants. Some may enter rivers, oceans, forests, or future living creatures. The cosmic voyage continues. The same atoms simply take on new forms. This endless recycling occurs everywhere in the universe. Stars recycle material. Galaxies recycle material. Planets recycle material. Life itself is part of a vast cosmic circulation that has been operating for billions of years. Nothing is entirely separate. Everything is connected through matter and time. There is something deeply comforting about this realization. When we look at the night sky, it is easy to feel distant from the stars. They appear remote, untouchable, almost unreal. Yet the connection between us and those distant lights is far more intimate than it first appears. The stars are not merely above us. Part of them exists within us. The same physical laws that govern galaxies also govern the atoms inside your cells. The same elements forged in stellar cores help your heart beat, your lungs breathe, and your mind dream. In a very real sense, the universe has become conscious through the material it created. The stars built the ingredients, time assembled them, life emerged, and now, billions of years later, the universe can look back upon itself through your eyes. As you relax tonight, imagine those ancient atoms continuing their endless journey. Picture them drifting through glowing nebulae, passing between stars, traveling across spiral arms of the galaxy, witnessing supernova explosions, watching new suns ignite, eventually gathering together to become oceans, mountains, forests, and living beings. Their voyage has lasted billions of years, and somehow, against all odds, it has led here, to this moment, to this quiet night, to you. Perhaps that is one of the most beautiful truths astronomy reveals. You are not separate from the cosmos. You are part of its ongoing story, a temporary arrangement of ancient atoms that have traveled farther than imagination can easily grasp. And somewhere far in the future, long after this night has passed, those same atoms will continue their journey among the stars once again. A few stars have survived since the earliest chapters of cosmic history, preserving clues from near the beginning of time. Imagine finding an object so old that it has witnessed nearly the entire history of the universe. Not an ancient ruin, not a fossil buried beneath Earth, not even a planet. A star that began shining when the universe was still young. A star that was already ancient long before Earth formed. A star whose light has survived while entire generations of worlds, stars, and galaxies came and went around it. Tonight, as we continue our quiet journey through the cosmos, we travel farther back in time than ever before. Not by moving through space, but by searching for some of the oldest survivors still shining in the darkness. The universe is about 13.8 billion years old. That number is almost impossible to truly imagine. Human civilization occupies only a tiny fraction of that history. Recorded history covers just a few thousand years. Agriculture appeared roughly 10,000 years ago. The dinosaurs vanished 66 million years ago. Even Earth itself is only about 4.5 billion years old. Yet, scattered throughout our galaxy are stars that may be more than 13 billion years old. These stars were already shining when the Milky Way was still assembling. They witnessed the earliest ages of cosmic evolution. In a sense, they are living fossils of the universe. Most stars are born from material enriched by earlier generations. Each generation creates heavier elements and returns them to space. The next generation forms from that recycled material. As cosmic time passes, stars gradually become richer in elements such as carbon, oxygen, silicon, and iron. This allows astronomers to estimate the age of stars. Ancient stars contain remarkably few heavy elements. They formed before many of those elements existed. Their chemical composition acts like a cosmic fingerprint. By studying it, astronomers can identify stars that originated near the dawn of galactic history. Some of these ancient stars orbit quietly through the Milky Way even today. They move through the galaxy like elderly travelers, carrying memories from an age almost beyond comprehension. One of the most remarkable examples is a star known as HD 140283. Astronomers sometimes call it the Methuselah star because of its extraordinary age. Measurements suggest it formed more than 13 billion years ago. That means this star appeared not long after the universe itself emerged from the darkness following the Big Bang. When this star ignited, there were no planets like Earth. No forests, no oceans, no living creatures. The sun did not yet exist. The Milky Way itself was still growing. And yet this star continues shining today, patiently, quietly, steadily. Its light crossing space as it has for billions upon billions of years. There is something deeply calming about such longevity. Human lives feel brief. Even civilizations rise and fall quickly compared to cosmic history. But these stars endure. Generation after generation passes beneath them. Entire species appear and disappear. Continents shift. Mountains rise and erode away. Still, the ancient stars continue their silent journeys. Many of these stellar elders reside within globular clusters. These dense, spherical collections can contain hundreds of thousands of stars packed tightly together. Some globular clusters are among the oldest structures in the Milky Way. Their stars formed during the galaxy's earliest years and have remained gravitationally bound ever since. If you could stand on a planet inside one of these clusters, the night sky would be astonishing. Thousands of stars would blaze overhead. Some would shine far brighter than our full moon. The darkness between stars would nearly vanish. And among those countless lights would be suns that have survived almost since the beginning of time. Globular clusters are like cosmic museums. Every star inside them preserves information about an ancient universe. By studying these clusters, astronomers learn about conditions that existed billions of years ago. They reveal clues about how galaxies formed, how stars evolved, and how the earliest elements spread through space. In many ways, these clusters function as natural time capsules. They have preserved evidence that would otherwise be lost forever. The oldest stars are not necessarily the brightest. In fact, many ancient stars are relatively small and dim. Their secret is patience. Massive stars burn furiously and die young. Smaller stars consume their fuel much more slowly. Some can survive for extraordinarily long periods. Red dwarfs, the most common stars in the universe, may continue shining for trillions of years. That is far longer than the universe has existed so far. Remarkably, none of the first red dwarfs have had enough time to die yet. Some of them may still be shining exactly where they formed billions of years ago. Imagine a star quietly glowing while galaxies collide around it. While black holes grow. While entire star systems form and vanish, the star remains, a tiny point of light enduring through ages of change. Ancient stars also help astronomers understand the earliest generations of stars that no longer exist. The very first stars were likely enormous. Many were hundreds of times more massive than the Sun. They lived brief lives before exploding as powerful supernovae. None have survived to the present day, but their fingerprints remain. The oldest stars contain traces of elements forged by those vanished pioneers. By studying ancient stars, scientists reconstruct stories of stars that disappeared billions of years ago. It is cosmic archaeology on the grandest scale. Instead of digging into the ground, astronomers search the sky. Instead of pottery fragments, they examine starlight. Instead of ancient ruins, they investigate stars older than almost everything around them. The deeper we look, the farther back the story reaches. Even galaxies contain ancient survivors. Some dwarf galaxies orbiting the Milky Way appear to contain stellar populations that formed shortly after the Big Bang. These small galaxies act like preserved fragments of the early universe. While larger galaxies experienced dramatic changes, mergers, and bursts of star formation, some dwarf galaxies evolved slowly. As a result, they retain clues about conditions that existed billions of years ago. Looking at them is like opening a forgotten chapter of cosmic history. Perhaps the most astonishing thought is that these ancient objects continue sharing their stories today. Every photon reaching Earth from an ancient star carries information from the distant past. That light traveled across unimaginable distances before arriving here. Some of it began its journey long before humans existed, long before civilization emerged, long before the first animal walked on land. Yet tonight, it reaches our eyes, a message delivered across billions of years. The universe has an extraordinary way of preserving memories, not through books, not through monuments, but through light. Ancient stars are among the oldest storytellers in existence. They speak without words. Their language is starlight. Their history is written in chemistry. Their memories are carried across space by photons that have traveled for ages. As you relax beneath the night sky, imagine those ancient stars shining above you. Some have endured for nearly the entire history of the cosmos. They survived galactic collisions. They witnessed the birth of countless new stars. They watched planets form and disappear. They have seen more history than any object on Earth could ever record. And somehow, after billions of years of travel, their light arrives here, to this moment, to this quiet evening, to your eyes. Perhaps that is one of the most beautiful realities in astronomy. The oldest objects in the universe are not hidden away beyond reach. They are still shining, still sharing their stories, still reminding us that even in a universe defined by constant change, some lights endure for almost all of cosmic time. And tonight, those ancient witnesses continue their patient vigil among the stars. Our galaxy appears stable, but it is constantly evolving, stretching, twisting, and preparing for future encounters. When you look up at the night sky, the stars seem permanent. The familiar patterns appear unchanged from one night to the next. The Milky Way stretches overhead like a silent river of light, giving the impression of something ancient, steady, and unmoving. It feels eternal, as though it has always looked this way and always will. But appearances can be deceiving. Beneath that calm and beautiful facade, our galaxy is constantly changing, slowly, quietly, relentlessly. Every star is moving. Every cloud of gas is drifting. Every spiral arm is evolving. The Milky Way is not a frozen structure hanging motionless in space. It is a living system. A vast cosmic city containing hundreds of billions of stars, all participating in a slow dance that has been unfolding for billions of years. Tonight, as we continue our peaceful journey through the cosmos, imagine stepping far above the galaxy itself. Imagine looking down upon the Milky Way from millions of light years away. From that perspective, you would not see a static picture. You would see movement. You would see change. You would see a galaxy constantly reshaping itself. The Milky Way is a spiral galaxy. Its stars are arranged in broad curved arms that wrap around a bright central region. These spiral arms appear graceful and permanent, yet they are not solid structures. The stars inside them are always moving. In fact, the Sun is currently traveling around the center of the galaxy at roughly 220 kilometers per second. That is fast enough to travel from New York to London in less than 30 seconds. And yet we do not notice this motion because everything around us is moving together. The entire solar system is orbiting the galactic center. Every planet, every asteroid, every comet, every grain of dust, all quietly circling the heart of the Milky Way. Completing one full orbit takes about 230 million years. The last time the Sun occupied its current position within the galaxy, dinosaurs had not yet appeared on Earth. Entire chapters of biological history pass during a single galactic year. As stars orbit the galaxy, they do not move like cars traveling on a highway. Some travel slightly faster, others slightly slower. Some drift inward, others drift outward. Over immense stretches of time, these motions gradually alter the structure of the galaxy itself. The spiral arms constantly evolve. Stars move into them, stars move out of them. New stars form, old stars die. The pattern persists, but the individual participants continually change. It is similar to a river. The shape remains recognizable, even though the water flowing through it is never the same. The Milky Way's spiral arms behave in much the same way. They are patterns of motion rather than permanent collections of stars. Meanwhile, vast clouds of gas drift between the stars. These enormous clouds can stretch for hundreds of light years. Within them, gravity slowly gathers material into dense regions where new stars are born. Every year, the Milky Way creates several new stars. Some emerge alone. others forming clusters containing hundreds or even thousands of stellar siblings. While old stars quietly fade, new stars ignite. The galaxy continuously renews itself. Creation and destruction occur simultaneously. Throughout its history, the Milky Way has also grown by absorbing smaller galaxies. Our galaxy is not an isolated island. It lives within a cosmic neighborhood filled with dwarf galaxies orbiting nearby. Over billions of years, gravity pulls many of these smaller companions inward. Some are gradually torn apart, their stars become incorporated into the Milky Way. Their gas helps fuel future generations of star formation. Even today, astronomers can detect long streams of stars stretching across the sky. These stellar streams are the remains of ancient galaxies that ventured too close. Their original shapes have vanished, but traces of their existence remain written across the heavens. The Milky Way is in part a collection of countless mergers that occurred throughout cosmic history. Pieces of other galaxies live within it. Their stars now share our galactic home. Perhaps one of the most fascinating discoveries in recent years is that our galaxy is not perfectly flat. Instead, parts of the Milky Way's outer disk appear warped. The galactic disk bends and ripples slightly, almost like the surface of a pond disturbed by a passing breeze. Astronomers suspect these distortions result from gravitational interactions with nearby galaxies. As smaller companions orbit the Milky Way, their gravity tugs on the galactic disk. Over time, those gentle pulls create enormous waves that travel through the galaxy. These ripples can span tens of thousands of light years. Entire regions of the galaxy rise and fall as part of these slow cosmic motions. The Milky Way is not a rigid structure. It breathes, it flexes, it responds to the gravitational influences around it, and its future holds even greater transformations. Far beyond the stars visible to the naked eye lies our nearest large galactic neighbor, Andromeda Galaxy. At this very moment, Andromeda is moving toward us. The distance between our galaxies is shrinking, not rapidly by human standards, but steadily by cosmic standards. In roughly 4 to 5 billion years, the two galaxies will begin a dramatic encounter. This event is often described as a collision, yet the word collision can be misleading. The stars themselves are so widely separated that direct impacts will be extremely rare. Instead, gravity will reshape both galaxies. Their spiral structures will stretch and distort. Long streams of stars will be pulled into space. Clouds of gas will collide and compress. New generations of stars may ignite. Over time, the Milky Way and Andromeda will merge into a single, larger galaxy. The night sky of the distant future will look completely different. Bright streams of starlight may arch across the heavens. Entire constellations will vanish. New patterns will emerge. Future astronomers, if any exist to witness it, will observe a sky unlike anything we know today. Yet even this enormous merger is only one chapter in an ongoing story. Galaxies continue evolving for billions of years. Stars continue forming. Black holes continue growing. Gravity continues sculpting the universe. Nothing remains exactly the same forever. And perhaps there is something comforting in that. The galaxy that shelters us is not fixed. It is dynamic, alive with motion, alive with change. Every star in the sky participates in that transformation, including our own sun, including the atoms that make up our world. As you relax tonight beneath the stars, imagine the Milky Way slowly turning around you. Picture its spiral arms sweeping through space. Picture newborn stars igniting within distant clouds. Picture ancient stellar streams tracing forgotten galactic encounters. Picture vast ripples traveling through the galactic disk. And far away, imagine Andromeda drawing ever closer. Not as a threat, but as the next chapter in a story billions of years in the making. The galaxy above you may appear calm and unchanging, but beneath that quiet beauty lies constant motion. A slow cosmic evolution unfolding across unimaginable spans of time. And right now, without noticing it at all, you are traveling along with it. Carried through the universe aboard a galaxy that has never stopped changing and never will. The universe is not something happening far away. It flows through every atom, every breath, and every moment of your existence. For most of human history, people looked at the night sky and imagined that the stars belonged to another realm, a distant kingdom, a celestial ceiling hanging above the world, something beautiful to admire, but forever separated from everyday life. Even now, when we step outside beneath a dark sky, it can feel as though the universe exists somewhere else, far beyond our reach, far beyond our concerns, far beyond ourselves. But one of the most remarkable discoveries in all of science is that this feeling is an illusion. The universe is not separate from you. It never was. You are not merely observing the cosmos. You are participating in it. You are part of an ongoing story that began billions of years before you were born and will continue long after every person alive today is gone. Tonight, as our journey slowly comes to an end, perhaps the most comforting thought of all is this: you have never been apart from the universe, not for a single moment. The atoms inside your body have traveled extraordinary distances. Long before Earth existed, much of the matter that would one day become you drifted through ancient clouds of gas. Some of it spent millions of years inside giant stars. Some of it survived tremendous explosions. Some of it crossed entire regions of the galaxy before eventually becoming part of our solar system. The calcium in your bones, the oxygen in your lungs, the iron in your blood, the carbon in every cell. Each atom carries a history older than humanity itself, older than civilization, older than Earth. When stars forged those elements billions of years ago, they could not know what they would eventually become. Yet somehow, through countless transformations, that ancient stardust became mountains, oceans, forests, animals, and eventually, you. The universe has spent billions of years rearranging itself into new forms. Today, one of those forms is a conscious mind, capable of looking back at the stars and wondering where it came from. That may be one of the most extraordinary things in existence. The universe has become aware of itself. Through countless living beings across countless generations, the cosmos has gained the ability to observe its own beauty, to ask questions, to feel wonder, to dream. Every breath you take connects you to this larger story. The oxygen entering your lungs was once part of Earth's atmosphere. Before that, it may have been locked inside rocks. Before that, it may have drifted through interstellar clouds. Before that, it may have formed within an ancient star. The atoms move. The forms change. The story continues. Nothing truly stands still. The stars above us are changing. The galaxy is changing. The universe itself is changing. And so are we. Every second, your body replaces enormous numbers of atoms. Cells are constantly repairing themselves. Molecules move from place to place. Energy flows through every living system. Life is not a static thing. It is a process, a continuous transformation. In many ways, we resemble the universe more than we realize. Both are dynamic. Both are evolving. Both are made of the same ingredients. When we look at photographs of distant galaxies, it is easy to imagine that they are completely unrelated to our daily lives. Yet the laws shaping those galaxies are the same laws shaping your existence. Gravity holds galaxies together. Gravity keeps your feet on Earth. The nuclear fusion inside stars releases the energy that eventually nourishes life. The same physics governing black holes also governs the atoms inside your body. The universe is not divided into separate stories. It is one story unfolding at many different scales. The stars, the planets, the oceans, the forests, the clouds, the people, all part of the same continuous process. Sometimes life can feel small. Our worries can seem overwhelming. The days pass quickly. Responsibilities accumulate. The future remains uncertain. Yet when viewed against the backdrop of cosmic history, there can be comfort in remembering that we belong to something much larger. The universe has endured tremendous change. Stars have exploded. Galaxies have collided. Entire worlds have formed and vanished. And through all of it, matter continued its journey. Energy continued to flow. New possibilities continued to emerge. You are one of those possibilities, a brief but beautiful chapter in a story that stretches across billions of years. And while individual lives may be short compared to cosmic time, that does not make them insignificant. In fact, it may make them more precious. Every moment of awareness is rare. Every experience is unique. Every sunset, every conversation, every memory, every dream, all are temporary. And because they are temporary, they matter. The stars themselves teach this lesson. Even the longest-lived stars will not shine forever. Galaxies will evolve. The universe will continue changing. Nothing remains exactly the same. Yet beauty exists precisely because moments pass. A sunrise is beautiful because it ends. A season is meaningful because it changes. A life is valuable because it is finite. The cosmos reminds us that permanence is not required for significance. As we have traveled together through these stories, we have visited ancient stars, distant planets, glowing nebulae, wandering galaxies, and invisible forces shaping the universe. We have explored objects larger than imagination and timescales longer than human history. Yet every journey has quietly led back to the same realization. You belong here, not as an observer standing outside the universe, but as a participant within it. You are connected to every chapter we have explored, connected to the stars that forged your atoms, connected to the galaxies that enrich the cosmos with heavy elements, connected to the ancient processes that made planets possible, connected to the long chain of events that eventually led to this very moment. Right now, as you listen, as you breathe, as you rest, the story continues. Far away, stars are being born. Elsewhere, stars are dying. Galaxies drift through the darkness. Black holes quietly shape their surroundings. Clouds of gas gather into future worlds. And here on Earth, another small part of the universe reflects upon its own existence. Perhaps that is enough. You do not need to solve every mystery. You do not need to understand every detail. The cosmos is vast beyond measure. It always will be. Simply knowing that you are connected to it is enough. Simply recognizing that you belong to this story is enough. Simply being here is enough. Thank you for spending this quiet time beneath the stars. As you drift toward sleep, remember that you are made from the same ancient matter that lights the galaxies. The atoms within you have crossed unimaginable distances. They have survived stellar explosions, traveled through interstellar space, and become part of a living world beneath a warm yellow sun. You are the latest chapter in a story billions of years old, and somewhere above you tonight, countless stars continue writing the next pages. The universe will keep expanding. The galaxies will keep turning. The stars will keep shining. And for now, you can simply rest. Let your thoughts grow quieter. Let the weight of the day fade away. Feel the calm rhythm of your breathing. Feel the gentle certainty that you are exactly where you belong. Rest peacefully, dream deeply, and let the universe keep watch until morning. Good night.